So now that you've had a chance to work through some of these questions, let's go over them. So we're going to start out pretty easy here. How many carbon atoms are found in a mole of carbon? And as we said before, 1 mole of anything, whether it's a mole of carbon atoms, a mole of methane molecules, a mole of water molecules, or a mole of elephants. That means we have 6.02 times 10 to the 23rd of that. For an atom, that's not that much. If you think about it, 1 mole of water, if you add up the mass, is only 18 grams. And if you know the density of water, which is 1 gram per milliliter, you know that that's just 18 milliliters of water. So it gives you another sense of how small an atom or a molecule is. 6.02 times 10 to the 23rd water molecules is only 18 milliliters of water, just over 1 tablespoon. On the other hand, I don't know if I'd want to picture a mole of elephants. So now we can move on to methane molecules. So how many carbon atoms are found in a mole of methane? So a mole of methane would mean that we have 6.02 times 10 to the 23rd methane molecules. Well, if each methane molecule has 1 carbon in it, the number of carbon atoms would just be exactly that, 6.02 times 10 to the 23rd. On the other hand, the number of hydrogen atoms would be larger. And the reason for that is because each molecule of methane has 4 hydrogen atoms. So there's 6.02 times 10 to the 23rd molecules of methane. To get the number of hydrogen atoms, we need to multiply that by 4. And we get 4.8, I'm sorry, 2.41 times 10 to the 24th. If we have 2 moles of methane, it's just going to be double that, or 4.82 times 10 to the 24th. All right, what's the mass of 1 nitrogen atom? For that, we just go right to the periodic table, and we get 14 AMU. 1 mole of nitrogen atoms is 14 grams. One mole of methane molecules, well, we did that one before, but that's 16 grams. Now for the rest of these, we're going to be doing some calculations. So here, if we have 49.55 grams of tungsten, how many moles do we have? And how many atoms do we have? So we can't find the number of atoms until we know the number of moles. So we need the molecular weight of tungsten. This is one of our unusual elements. It's abbreviated by a W, but we can look that up. 1 mole is equal to 183.84 grams. Grams go on the bottom, so we can cancel. And if we calculate that, we get 0.26 0.95 moles. Now, if we want to figure out the number of atoms, we're just going to take that number of moles that we got, and we're going to multiply that times Avogadro's number. And we get 1.622 times 10 to the 23rd atoms. We can do the same thing here for ethanol. So what's the mass of 1 mole of ethanol in grams? What's the mass of 1 molecule of ethanol in grams? So ethanol, we can see, has 2 carbons, 6 hydrogens, and 1 oxygen. So its mass for 1 mole, we can add those up, is 46 grams. Now, if we want to put that into AMUs, in other words, for 1 molecule, we know then 1 molecule would be 46 AMU. And so from there, we just need the conversion. 1.66 times 10 to the minus 24 grams per 1 AMU. And we can calculate that out. We get 7.6 times 10 to the minus 23rd grams. Now in part C, we're going to convert that number of moles of ethanol into grams. So we have 0.5933 moles. We already know the molar mass. We calculated it a moment ago, 46 grams per 1 mole. Gives us 27.29 grams. And now in part D, we're going to go the other direction. If we have 100 grams, how many moles is that? So our conversion factor now goes the other direction. We need moles on top, grams on the bottom, and we get 2.174 moles. And as you can see, we're going to gradually get a little bit more complicated here. In question 10, now we're trying to calculate moles, but instead of giving you the chemical formula, I give you the name of the compound. So you would need to start by converting the name back to the chemical formula. So ammonium is NH4+, phosphate is PO4 3-. So in order for our charges to balance, we need 3 ammoniums and 1 phosphate. And so we can go through and add up the masses of each of these elements. 14 for nitrogen, 1 for each of the hydrogens, making sure that we then multiply everything in the parentheses by 3. We get 31 grams for phosphorus and 16 for oxygen. So the total here is 149 grams. So now we can take our mass of ammonium phosphate times 1 mole over 149 grams is equal to 1.57 moles. Question 11 is a very similar problem. Zinc oxide. Again, we need to find the name or the formula from the name. Zinc gives us a 2+ ion. Oxygen is a -2, so we need 1 zinc, 1 oxygen. Molar mass here is 81.406 grams per mole. So 1.369 moles. And when you're abbreviating moles, you have to be careful. You want to abbreviate it as MOL. Just a lowercase m, we already know, means meters. We don't want to get those confused. So 81.406 grams on top, 1 mole on the bottom, gives us 111.4 grams. And then our final question here, what has a higher mass, 1 mole of oxygen or 1 mole of nitrogen? Well, we just need to add them up from the periodic table. Oxygen, O2, is going to be 32 grams per mole. So 1 mole of oxygen is 32 grams. And that's heavier than 1 mole of nitrogen, which is 28 grams per mole. So 1 mole of nitrogen is only 28 grams. So 1 mole of oxygen is going to have a higher mass than 1 mole of nitrogen.